Hi, my name is Chikamatera Felinda, and here I am going to explain a journal called Automation Using IoT in Greenhouse Environment. The topic is about implementing the IoT Internet of Things system in the greenhouse environment and will lead to the greenhouse automation. A greenhouse, also called a glasshouse or hothouse, is a building where plants such as flowers and vegetables are grown. The purpose of this greenhouse is the specific climatic condition for the area inside the greenhouse. Greenhouses were built due to the unexpected climatic change that occur due to the global warming. Growth of the seasonal crops such as the millets, beans, cotton, and sugar canes get affected and causing a decrease in the production rate. A greenhouse can maintain a proper climatic condition by perfectly controlling the temperature, humidity, soil moisture, and the light inside the greenhouse. Greenhouse will trap the heat and keeping the area warm enough to sustain plants' life, just like the greenhouse effect works. So, despite the greenhouse being very beneficial for the farmers, as it increases the yield of the crops and production rate, it causes a discomfort for the farmers as they have to keep a periodic check on the greenhouse by making a regular visits. And if the farmer fails to maintain the perfect climatic condition, then there is no purpose for the greenhouse itself. But after we implement the IoT and the embedded system, it could address the problem that I mentioned earlier, and will provide the automated controlling and monitoring of the greenhouse environment. It will replace the undeviating administration of the farmers. The concept of the IoT system is we will get the real data from the field such as the moisture, temperature, sunlight, and humidity, and the data will be processed using the controller, which is using Arduino 3. And the farmers will monitor the data and controlling the environment from the mobile device. This system will enhance the production rate and minimize the discomfort caused to the farmers. And next is the component used in this project. I will divide by three sections. First is input component, second is controller, and last is output component. For the input component, we are using moisture sensor. The YL69 moisture sensor is used to sense the moisture in the soil. The tau electrodes found in the moisturizer are placed in contact with the soil. Initially, when it is placed into the soil, the voltage fluctuates. An increase in the voltage is found if the soil moisture is less, and the voltage decreases with the increase in the soil moisture. Next is the HT11 humidity and temperature sensor. It is a digital sensor to monitor and gather information about the temperature and humidity that is prevailing in the greenhouse. And we have light sensor. This sensor enables an incorporated control of the greenhouse environments. GL4528 detects the light intensity of the environment. The output voltage of the light sensor changes based on the light intensity. Whenever the light intensity increases, the voltage sensed at the output is very high. And when the intensity of the light decreases, the output voltage also decreases. And for the controller is using the Arduino 3. Arduino is an open-source electronics platform using the .NET Micro framework. The Arduino is the vital core of this project. It is a single board, built with the Cortex M4 and 168 MHz and other specifications that we can see at the table in front of us. For the output component, we are using DC motor, relay, DC fan, motor pump, the L293D motor driver, and mobile device. This is the work diagram for the system. To overcome the drawback in the existing system, the preferred system uses the sensors to monitor the temperature, humidity, moisture, and the light. The sensors are connected to the input pins of the Arduino, and the output of the Arduino is given to the motors and relays to regulate the flow of the climatic condition. Based on the threshold value set for the temperature, moisture, humidity, and the light, the Arduino operates the driver circuit to regulate the flow of the air and the temperature. The Wi-Fi connectivity in the cloud enables to transmit the information gathered from the sensors to the cloud and get stored in the cloud database. The information stored in the cloud is regularly transmitted to the farmer's mobile device over the internet to initiate the remote monitoring. This enables to elude the human-to-machine interaction and provides a machine-to-machine interaction. Next, we are going to talk about the IoT data collection technology and process. But in this journal, there's not enough information that describes about the method, such as what kind of method used for data collection or the research type. So I have these 5 layers that I got from another source. This is the method for IoT data collection that highly recommended to build the IoT system. The first is device layer. In this layer is meant for the device in the field, either for collecting the data such as sensors, or for processing the data such as Arduino or others controller, and also actuator that do the action such as motor. The second is communication layer, which is the Internet protocol used for the system. This part of the architecture allows devices to communicate with each other and exchange data. The communication layer consists of protocols such as HTTP or HTTPS and other. The third layer is ITH layer. This layer is often considered the application's command station as it brokers communications. In an IoT application, it carries out the following functions such as device management, ensuring processing security, aggregating and replication data, and routing data to or from the cloud. The IoT layer helps ensure the most data processing is happening of the connected device in a dedicated environment. Next is the event processing layer. After IoT data is collected, an application needs to process and store it. This happens in the event processing layer of the system. In this layer, multiple operations are handled, such as cleansing the data, storing the information inside the database, and adding metadata to IoT data. The last is client communication layer, which is the user interface. In this layer of the IoT architecture, all collected data is transferred from device-oriented to a user-oriented system. To relay data from IoT device in the greenhouse to end users, the team needs to build user interface that interact with database and the back-end device. The most common way to relay IoT insights to an end users is via website or by mobile application. So from the IoT architecture, we can analyze the things to consider when collecting the IoT data. First, we have to create secure and reliable data collection and processing practices inside the system. So next is ensure that a device is capturing relevant real-time information. Third is considering the scale and industries IoT devices are deployed in. The fourth is developers need to integrate security into all layers of IoT application. And last is using metadata and assign meta tags to existing IoT data to sorting different types of data. Here we are at finding and discussion section. As we can see in front of us is the picture of hardware setup used for the IoT system. For the first picture on the left is the user interface used through mobile application. As we can see, we have parameters for control and monitoring the climate in the application. The first parameter is for monitoring the life cycle of the plants, which is been 22 days. The second parameter is for monitoring the growth phase, and it's shown the current phase was vegetative. During the vegetative phase, plants are busy carrying out photosynthesis and accumulating resources that will be needed for flowering and reproduction. The third parameter is for monitoring whether it's night or day. The fourth and fifth parameter is for controlling the lights on and off time. The sixth parameter is for controlling the temperature in the room. This parameter will control the cooler. The eighth parameter is for controlling CO2 set point. This parameter will control the sliding window to maintain the CO2 level in the greenhouse and so on. And as we can see, there's a comment or message for the farmer that the farmer have to empty and clean the reservoir. If the crop cycle is complete, the farmer will get satisfactory results. By controlling the climate in the greenhouse, the proportion of crop failure will be reduced and the farmer can increase production because plants can grow anytime and are not affected by the weather. For the second picture on the right is the snapshot of the result visualized by employing the automated greenhouse system that is equipped with the coolers, sliding windows, and the sensors. And finally, we are at the conclusion part, and here my conclusion through the journal. First, the automated system for the greenhouse management, including control and monitoring, in the paper is now done by employing the IoT system, using sensors of temperature, moisture, humidity, and the light for monitoring of the environmental changes, and using the Arduino to regulate the driver circuits to maintain the normal climatic condition within the greenhouse. Second, the remote monitoring and control of the greenhouse is enabled in the system using the IoT platform and the cloud services that store the information and sends the regular SMS alerts to the farmer about the room condition. And the result of perfect system using the Arduino will ensure production increase and stress reduction for the farmers. The utilization of the IoT system in this greenhouse can also be further developed. This system can be used to grow and care for rare plants that are difficult to grow in harsh climates.